Hello! In this video, we're going to discuss the required practicals entitled Measuring the Specific Heat Capacity. The aim of this required practical is to determine the specific heat capacity of a metal block of known mass by measuring the energy transferred to the block and its temperature rise using the equation for specific heat capacity. Recall that the specific heat capacity of a substance is the energy needed to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. Let's start with our experiment. We're going to heat a metal block of known mass. First of all, we're going to measure the mass of the aluminum block using a top-pan balance. Let's place it on the balance and read the result. The balance reads 60 grams as a mass of the aluminum block. Now we're going to let the block heat and we will use the energy meter or the joule meter to measure the energy supplied to the block and the thermometer to measure its temperature rise. First, let's assign its initial temperature before heating. The thermometer reads 10 degrees Celsius. Now let's heat it. Notice how the temperature is increasing. Well, the temperature reaches a maximum value of 100 degrees Celsius as a final temperature, and the energy meter reads 4,860 joules as supplied energy. What changes to energy stores occur as a result of the transfer of energy to the block? When the energy is transferred to the block, its temperature increases and so does its stored energy. Now let's use the specific heat equation to find the specific heat capacity of aluminum. Recall that the specific heat capacity is given as energy transferred delta E in joules is equal to the mass m in kilograms multiplied by specific heat capacity symbolized as small c measured in joules per kilogram per degree Celsius multiplied by the temperature change symbolized by delta theta measured in degrees Celsius. We can rearrange the equation in a way to find the specific heat capacity. The specific heat capacity C is equal to delta E divided by m multiplied by delta theta. Let's substitute the values of delta E, which is the energy transferred measured by the energy meter, which is equal to 4,860 joules, the mass of the aluminum block, which is 60 grams, and we should convert the unit from grams to kilograms by dividing it by 1000, so the mass is equal to 0.06 kilograms, and the change in temperature read by the thermometer. So delta theta is equal to theta final minus theta initial, the final temperature reached by the aluminum block minus its initial temperature. The final temperature read by the thermometer is 100 degrees Celsius and the initial one is 10 degrees Celsius. So the change in temperature is equal to 100 degrees Celsius minus 10 degrees Celsius gives an answer of 90 degrees Celsius. Therefore, C is equal to 4,860 joules divided by 0.06 kilograms multiplied by 90 degrees Celsius gives an answer of 900 joules per kilogram per degree Celsius. Therefore, the specific heat capacity for aluminum block is 900 joules per kilograms per degree Celsius. Now, replace the block with an equal mass of water in a suitable container and measure the temperature rise of the water when the same amount of energy is supplied to it by the heater. By doing so, we notice that aluminum heats up more quickly than water. This is because water has higher specific heat capacity than that of aluminum, The specific heat capacity of water is 4,200 joules per kilograms per degree Celsius. However, the specific heat capacity of aluminium we have found it to be 900 joules per kilogram per degree Celsius. So since water has higher specific heat capacity than that of aluminium, so that they warm up slowly when the heater element is on and cool down slowly when it's off. That's why they heat slower than that of aluminium. Don't forget to wear eye protection and take care with the hot immersion heater. That's all. Thanks for watching.